Okay guys, this is for Math 2. This is factoring and solving quadratic equations. First I'm going to start off with this front page is all a review of factoring. Now, you probably spent days doing factoring in Math 1. We're really just trying to review. I'm just trying to touch some highlights and remind you of what some things are. We won't spend as many days on it this time. So we start off talking about what the product is. We know that's the answer to a multiplication problem, and that our factors are the actual numbers we multiply. So for example, over here on the side, I've got 3 times negative 4 equals negative 12. And we know that the 3 and the negative 4 are the factors, and the negative 12 is the product. So we just do a little practice here with each of these, and I'll let that run. Notice each of these are factors of that given number. They will multiply to give you that given number. Notice I'm trying to take care of the positives and the negatives. Trying to take care of the positives and the negatives and generate this list. Now sometimes I'm not going to write down this entire list, but this is just a little review. You know, you did this several years ago. You'd write down a list and write down every single one. Some more remembering. Now we're into algebra land. Okay, we got a little distributive property problem here, and it gives you x to the third plus 2x squared. But my question for you is, which one's the product and the factors? And you can see that these two are actually factors, and that's the product. Same thing here. I hope you remember how to do this. Yeah, it's the FOIL method. And again, just a reminder as to these two binomials are the factors. So when I have a trinomial, I normally have two binomials as the factors. Okay, our GCF factoring is the greatest common factor, and we want to know what is the biggest number that will go into all of the terms. So we're going to look here. Now what I did, of course, was I wrote down the factors of 3x squared. That's 3 and an x squared. 3 times, see, it's multiply, so it looks just like up here. And I wrote down here 3 times 2, which again, those are factors. Which ones are in common? They both have a 3, so that's the GCF, that's the common factor. Alright, now I did a lot of extra work here. We were just kind of talking in class about the fact that this was being multiplied and this was the other factor. If you take that and distribute it, it'll end up being this. Now we don't ever write it down like that. We normally skip right from here to here. So just a little review of this is some of the stuff that's going on in your head. Let's try this one, do a little less writing. Okay. Immediately I can see that a 2 goes into each of them. So 2 is a common factor, but there's actually some x's that are a common factor too. Okay, and I hope you recognize that each one of these terms has 2 x's, so it has x squared in each term. So that leaves us with a 2 and an x squared as the common factor. Now, you can figure out what's left over just by eliminating those. And you can see in this first one I have a 1 and 2 x's, so that's 1x squared right there. This second one, I've got a 3 and an x left over. And in that last one, the only thing left is a 9. Alright. A lot of people are tempted to pull this out right here and say that x is a common factor and leave this here, but what ends up happening is we generally don't like to leave a negative right here. So I'm going to figure out that there's actually one more factor in each of these. So I'm going to get rid of that, and I'm going to pull out a negative 1. We already know 1 will go into everything, and if I pull out a negative 1, it'll just switch all them signs. So notice negative 1x times x squared would give me negative x third. Negative 1x times negative 4x would give me positive 4x squared. And of course, negative 1x times 1 is negative 1x. Now when we have trinomials, we have a little set to go through here. This first example, I'm going to run through the long, hard, painful way, which is perfectly fine, but I just want to make sure that we're good with it. And then we'll try to do shortcuts on the rest of these, because remember, this is a review. So we remind ourselves that the coefficient's the number before the variable. So you can see right now that I multiplied the coefficient of 1 and the coefficient of 6 and got a 6. Now step number 3 told me to find all the factors of step number 2. So here I'm writing down all the factors of 6. And for step number 3, I'm looking for the factor that adds to give me the middle term. And that factor right there is the 2 and the 3. Okay, like I said, a lot of this normally happens in our head, but if I take that 5x and break it up, right here we know 2 plus 3 is 5, so if I just change that to 2x plus 3x, it makes a slightly more complicated problem. But the good news is, I can look for the GCF of these two small groups. So just like we did GCF a minute ago, I'm going to do GCF here and here. And hopefully what's going to happen is I'm going to have a match. And look right here, I've got x plus 2 and x plus 2. So I remind you, that is the long way. I don't want you to do the long way unless you have to. I want you to use the shortcuts that you remember from last year. So here's a little less work. Okay. I go through, I'm looking for numbers multiplied to give you negative 32. So here's all the factors. And this factor happens to add to give me 4. So I'm able to jump right to the answer. And you guys recognize that all this GCF factoring happens in my head. I don't even have to do that because of the shortcut, because these end up being easy problems. I know it's an easy problem because there's a 1 coefficient in front of the x squared. So I'm looking at this next one, there's a 1 coefficient, this should be easy. Now this time, look, I didn't even write down all the possible factors. I just wrote down the one that I knew was going to add up to give me the negative 11. And again, I know this is a fast review, but in class we took our time, did a little discussion. Now this one down here looks a little more complicated, but it's not. When I do my first step and I factor out any GCF, look what ends up happening. I end up with a 1x squared right here, which means this is actually an easy problem. So I'm looking for the negative 15. These two will add up to give me 2. And I'm good. Same thing on this one. If there's a GCF, take it out first. And there is a GCF of 3x. I did write the problem down wrong. You'll want to check your notes to make sure there's an x on that. It was a typo, that's my fault. But if you fix that typo right here, then this GCF works. Okay. I did have another typo on this last one, so if you'll make that correction first, then we're going to be able to work through it. Actually, let's skip this one. I think this one ended up being prime. I will play it, but it ended up being prime. It was a bad example. Nope, I'm wrong. I'm thinking of a different problem. This one does work. GCF factoring, and then trinomial factoring. Now, these last three, there is no GCF. I look at the three, it looks like it's going to be hard, and there is no GCF. So here's where I have to do it the long way. 3 times the 4 is going to give me a 12. So the 12 is the one I'm going to look for the factors of. So the 1 times 12 and then 1 plus 12 will give me the 13. I'm going to break that up. And now I'm going to look for common factors in those small groups. And what I hope happens every single time is I hope that we have a match. And I do have a match. So I have 3x plus 1 and x plus 4. This one, same idea. I checked for a GCF, and guess what? There is no GCF. And there was no typos, so I had to do it the long way, 3 times 32. We were able to figure out that 24 times 4 gives me that 28. It gives me the 96, and then it adds to give me 28. I'm going to group these together and look for a GCF. So the GCF of this first group is 3x, and the leftovers is x plus 8. The GCF of the second group is just a 4, and the leftovers is x plus 4. And you can double check that just by distributing here and distributing here. And look, you did have the match, so you're good. This is the one that is a prime, so I'm just going to skip that example. Alright. Okay, that was a quick review of a lot of our factoring. Now we actually get into the why we use factoring part, and that's up here. The zero product property tells us that if I multiply two numbers together, for example, any two numbers in the world, and I get a 0, then one of these two numbers must be a 0, and that's a zero product property. So we're going to use that in the fact that we know how to factor to solve. So my directions here say solve. Step number 1, make the equation equal to 0. It already is. Step number 2, GCF. So I did have a GCF, so I factored it. And now I want you to look. I have 2 that equals 0, just like this. I have a factor, 2 factors, just like here, that are equal to 0, which means one of those factors is equal to 0. So I'd take my 2 factors and split them up into 2 small mini equations, and I solve each mini equation. And you can see that my answers are x equals 0 and x equals 9. Same process on this one. First things first, make it equal to 0, which I did. Then factor it. Which I did. Factored it from the front side. Now remember, one of these 2 factors must be equal to 0. And if I solve the 2 mini equations, it gives me the answer. Alright. Your homework is 8 through 24 even. If you have any questions, see you tomorrow.